Hello students, today we are going to be taking notes and learning about solving systems of equations by graphing. Don't forget as we go along to take notes and do the completion survey at the end of the video. What is a system of equation? A system of equations is when you have two or more equations using the same variables. The solution to the system is the point that satisfies all the equations. This point is written as an ordered pair, x, y. When graphing, you will encounter three different possibilities when you have two linear systems. So let's take a look. As you can see at on the graph, this is what a system of equations might look like. This is when we have one point at which these two lines are crossing. Since the two lines cross once, there is one solution, which is why they cross one time. The solution to this on the graph is 1, 2. So we go over 1 and up 2 to the point at which the two lines cross. Remember, when you're writing your ordered pair, x always comes first and then the y value. We can have two lines that are parallel. These lines never intersect, which means we would have no solution. Before, we saw that the point where the two lines cross is called a solution. Since these two lines are never going to cross, that is why this is called no solution. Parallel lines have the same slope with different y-intercepts. As we can see on these lines, on the first line we're going up 2 and over 1 for a slope of positive 2. And on the second line we're going up 2 and over 1 for a slope of positive 2 as well. The y-intercepts are different on this one. One of the lines crosses up here at a positive 2, the other line crosses down here at a negative 1. But since they have the same slope, they are parallel lines, which means there are no solutions. The last type of solution we could have with two linear equations would be two lines that are exactly the same. These two lines always cross each other, so it's called infinite number of solutions. Coinciding lines have the same slope and the same y-intercept. On this one you can see we're going up 2 and over 1, and that's for both the red and the blue line. And then their y-intercept is both negative 1. Since they're exactly the same line, we have infinite number of solutions, which means any point on either of the two lines is going to work as a solution. So, if we take a look at this real quick, what is the solution of this system graph below? Take a second and see if you can figure this out. Is it 1, 2, negative 2, 2, negative 2, 2, 3, no solution, or 4, infinite number of solutions? Remember, when you're writing an ordered pair, x comes first and then y. As you can see on this one, they do cross, so we know it's not no solution. They are two different lines, so we know it's not infinite number of solutions. So now we're down to these two. If we want to graph this ordered pair, we're going to do our x value first. So if we start at 0, we're going over positive 2 and then down negative 2. So the correct answer on this one is going to be 1 to negative 2. And that is where our two lines intersect. We can also have a system of linear and exponential graphs. This one on here, the first solution we can have is no solution. No solution means that the two functions never cross. Since this is one exponential and one linear, there are no similar slopes, they do not have the same y-intercept, and there's no point at which they cross. You can see there's always a gap in between the two lines, and even as we extend these lines up, they are never going to cross, so we call this no solution. Another type of solution we can have is one solution, just like before when we had two linear lines. This is called one solution because they're only going to cross one time. Again, when you write the solution of this system, you're going to write it as an ordered pair. So to get to this point up here, if we start at 0, 0, we're going over 2 and up 4. So that is why our point is 2, 4. This is the only point that these two will cross, which is why we call this one solution. The last type of solution we can have is actually two solutions. These are two solutions because, as you can see, our lines cross at two different points. They're going to cross at negative 3, 8. Again, your x value comes first and then your y, and then also at 0, 1. We cannot have this with two linear equations because two linear equations would be impossible to cross twice. but this can happen with exponential. There is no such thing as infinite number of solutions with a linear and exponential system because there are two different lines and they're never going to go on the same path. Alright, keep in mind, we will graph the linear functions just like we did before with slope-intercept form, knowing that b is the y-intercept, and then we use the slope, rise over run, to get our next point. Tomorrow in class, when we practice these, you will be graphing these in order to find the solution at which they cross, so please keep that in mind. You will also be graphing exponential functions again, just like we did before when we made the table from -3 to 3. You'll do the same thing. You'll use the exponent button on your calculator, and you'll draw the graph from there. Make sure you know how to do this for tomorrow. If you need to look back over your notes or rewatch another video, please do so. So, as this video went along, make sure you have taken notes, completed all the notes on your work notes page. Go take the survey now. Don't forget to do that because you will get points taken off, and bring your questions tomorrow to class.